Hey, everybody. Thank you for joining our webinar today. It's just one now, so I'm sure folks are going to be rolling in, but we're just going to get going here because it's going to be on for a bit. Uh, Happy to have the guys from Ace Labs, Max and George here joining us for a talk on recovering data from SSDs. Um, we were at their partner event a couple of months ago, and they did this presentation that I thought was pretty interesting in essentially where data from SSDs was originally kind of lost forever. They're finding ways to recover it. So I thought it would be a good one for the community and all our folks that are Ace Labs users or interested in the Ace Labs products. So they're going to get cracking here in a minute. Just a little bit of, I guess, shameless plug. We've got a couple of classes coming up in March and June, at the end of June. We're bringing the Ace Labs training back, and we're very excited about it. It's a combination class for their HDD and SSD training, 5 days here in Norwalk, and we'll be delivering it fairly regularly after that as well. The course is going to be taught by Dai Shimagoto, who I just butchered his name, but he is a longtime user of Ace Labs. He's the CEO of Air Force Japan Data Recovery. He holds one of the premier qualification for forensics examiners there as a certified digital forensics practitioner, stumbling over my words. Very well qualified. He contributes to the global standards, member of IEEE, holds some patented technology related to HDDs, and presents his research to such conferences as Cold Blue and HTCIA. We're really excited to have him. He's a great guy and a great teacher. Yeah, we're really pretty happy about the fact that we're getting started here again with ACE. Without further ado, I'm going to hand it over to Max and George, and we'll get started. Elizabeth is on as well, and she's putting some notes down in the chat area. So please feel free to ask away questions in the chat. I think the guys will either get to them throughout or perhaps at the end, but I'll let them make that call. Thanks again, everybody, and look forward to this webinar with y'all.
Thank you, Bill. So I think we
Take
can
it away,
start.
Max.
Yeah.
Yeah, go ahead.
All right. Okay, ladies and gentlemen, thank you so much for your time for coming here today. I don't think take it will take up to maybe 1 hour, 1 hour, 20 minutes. So let's start. Today we're going to share our technologies in terms of the quick formatting of the SSD. And I'm sure maybe some of you guys know our company. Just a brief introduction of myself. I'm Max, and I've been working at Ace Lab for more than 12 years, helping people to build the data recovery, digital forensic labs, and I'm also a member of Interpol Digital Forensics Group. And we are sharing our experience with other digital forensics experts, how to build, how to equip the labs using our solutions, and to succeed with the investigations of really complicated cases. So, and most of you guys already know about Ace Lab, but just a few of you who are just still thinking about our solutions. We are pretty famous in the data recovery industry and as well as digital forensic industry because we are like a part of digital forensics ecosystem for today. And our solutions have been supplied for more than 140 countries, and there are more than 20,000 customers worldwide are using our tools. And of course, we're famous not only in our solutions, but excellent technical support services, assistance, including training, technology, training centers, training programs as well. So, and right now, PC3000 and Ace Lab company are very famous and internationally recognized as the pioneer and leader in data recovery area. And as you know, we've been starting our business for more than more than 32 years ago. So it's a little bit big period, long distance, so when we are providing good, excellent solutions for your challenges. So, and over the last 32 years, we are providing different solutions for different types of storage medias. And today, as I mentioned, we're going to talk about SSD drives, NVMe, and not only NVMe interfaces. And George will going to make some master classes. And if you know, maybe if you don't know, but the tendency, the popularity of SSD drives have been rising year by year. And if you take a look at the graph, the annual increase of the SSD popularity is up to 26% year by year. And if you see by 2030, it's going to be at around $350 billion. So it's a pretty big market. Of course, right now it's a little bit slowed down because of the OpenAI guys. Yes, they just increased the price for the SSDs, but I'm sure this is just matter of time when the SSD prices are gonna back to the normal level. So at least I hope so. So and in October of last year, we had a tech week, which lasts 3 days in Croatia, and we provided opinion poll at the round table. And at this round table, we provided some questions for the people, for data recovery engineers about could you please prioritize what kind of issues of the SSD drives you're mostly bothering with? And on the first place, as you can see, people voted for the firmware problems like damaged translator, no passport information, or maybe busy state. On the second place, people voted for the bad sectors during the imaging. And on the third place, there were deleted data and formatted partitions. And another challenge was related to the PCB issues based with the hardware corruptions. So, and another story when we asked people, how often do you get formatted SSDs in your labs? And 33 people from the audience provided information to us that almost all cases have firmware problems, 33 people. And 15 people mentioned that half of the drives are formatted. So later on, if you have some free time, we can also provide some kind of interactive opinion poll in the end of this webinar. And we can also understand whether this topic is really indeed very hard for you guys. So, and OS Lab provides very specific solutions which are very unique because nobody else in the world can provide the same approach and the same solutions for the damaged SSD drives, and especially for the NVMe. How we're doing this? We're doing this dealing with a technological level. It means that we send some technological commands to the damaged SSD, and we are sending our firmware codes instead of the damaged firmware code. And because of this, we are making SSD drives alive and make it possible to recover data. So, what do you usually doing with deleted and formatted data on the SSD? And right now, I'd like to pass my word to George, who is a Lab instructor and technical support engineer for more than 7 years, and he has been working with Lab more than 7 years and solved thousands of cases, including some physical problems. And he is a very great expert on the SSD NAND-based storage media devices and as well as hard disk drives. And today, George going to share some technical information, including real-life case demonstrations. All right. So, George, please go ahead. I'm going to stop my screen right now, and I'm going to allow you to share your screen, please.
Okay, thank you, Max. Thank you, Bill. Thank you guys for attending this webinar. It's a pleasure to be here, and it's a pleasure to actually let you know about one of our latest updates, one of our latest features that we added to our PC3000 tools. And actually, recovering data from formatted SSDs, it's a really, really big issue nowadays, because when we introduced this feature, we noticed that we get a lot more tickets connected with these kind of issues. So it looks like that guys before were scared of working with formatted SSDs, or maybe if not scared, maybe they were just unable to understand what to do. And now the solution is actually presented, and now I would like to share with you how we can actually deal with them. So first of all, let's find out and let's see the differences between different types of formatting. And in data recovery field, I would say that quick format is the most popular out of them all, because it's easy, it's quick, obviously, and a lot of people can accidentally do the quick format. I am sure that some percent of you guys during their career may format the drive accidentally, and we are like in the same boat with our customers. So the biggest difference is pretty obvious. Quick format is just fast, and actually it is not like fully rewriting anything on the drive. It's just create a new file system over the old one. And full formatting, on the other hand, it's the slow process, depending on the drive, of course, but it's a lot slower than the quick format because it's physically overwriting the whole partition, like sector by sector, filling it with zeros or with some specific pattern if you are using some specific tools. So both of these options can be done in Windows, and because of that, again, quick format is one of the most popular issues connected with the SSDs. Of course, after the firmware corruption, which Max mentioned in the beginning. So this is the example of how quick format on any media storage device works. So before quick format, we have our old user data plus file structure metadata available for working, for accessing, and so on and on. And after quick format, what is actually happening? The new file system metadata is added to the drive, and drive actually thinks that, all right, the previous data is now deleted, so I can write over it. But it is not physically rewriting anything at this point of time, at this position. And in this case, it's not a very big deal, and it is not a very big problem for you to recover the data, because a lot of user data and file system metadata still remains on the drive. So metadata can be searched, it can be analyzed, it can be parsed, and this will give you access to user files and folders. Because again, if you take a look here, the biggest part of the old data is still available for you. So these things can be done not only with some high-end specific data recovery systems, but some free or some low-priced data recovery software can help with these cases as well. And if there are no additional problems with the drive, like firmware issues or something like this, it's not a problem for such operations to be performed. And of course, PC3000 systems can also do this job without sweating, so it's not a very big issue, and such possibilities can be done. I mean, such things can happen, for example, on hard disk drives. And to quickly summarize what I just said, after quick format, most of the data will still remain on the hard disk drive. All the things that I just mentioned was about the hard disk drive. There are a lot of software and tools that can help you in this case, and chances of data recovery are very high. And this was true until the introduction of the of the SSDs, which are appeared on the market. And this is like graph of how many cases of hard disk drives and SSDs we are noticing over the year in our technical support department. So when I came to AceLab, I could definitely say that most of the time we were working with hard disk drives. But with each year, the amount of SSDs were growing. And right now, in some days or in some weeks, we can receive more SSDs than the hard disk drives. And this trend will only proceed further, and I would not say that we will at some point finish working with hard disk drives. Of course not. It's still a very valuable purchase regarding the media storage devices. Yeah, but for those who are working with modern laptops, modern PCs, some maybe gaming machines, all of them are already using NVMe SSDs, and you need to be like up to date with that. So how SSDs are working? It's obvious, but again, to better understand, the speed of operations on SSDs, they are very fast. They are able to read very fast, write very quickly as well if we are talking about an empty space. But if we are talking about overwriting the data, or changing the existing data, it will take a lot more time on even fastest PCI Express 5.0 generations of SSDs. So this is just the limitation of the technology, of the way how data is being stored on the SSDs, and this is what we need to, not we, but manufacturers of SSDs need to work with. So what we can do, what operating system of our PC can do with SSDs. We can read the data, we can write the data, and we can get the information about the capacity, about the serial number of the SSD, and operating system can also have the possibility to trim the data. For a very, very long time, these four letters, this trim command, was like a nightmare for data recovery laboratories and offices. And nowadays, actually, we are facing trim on a lot of different types of media storage devices, on modern hard disk drives, and of course on pretty much all SSDs. And if we are talking about reason why trim is available on such a lot of different types of media storage devices, it's because if you're writing without trim or overwriting the previously recorded data, this process will take a lot of time because, again, of the technology which SSDs are using. And if we are talking about writing after trim or when trim command is enabled on your SSD, the idea is that in the background, the SSD will rewrite the existing data with the zeros, and the next time when you need to write something, it will write to empty blocks, which will be a very quick process. So this is basically how it works. We have the SSD, which has its CPU and the data located on the NAND memory chips. So blocks with data are used, blocks contains information, and SSD returns data when you are trying to communicate with it. If you deleted something or quickly formatted the drive, the trim command will be received by the drive from operating system, and the data will be actually hidden from the operating system, and blocks will no more be in use, but for some period of time, the data will still be located on the memory chips. But SSD will think that it is zeroed, it is completely rewritten, but physically it is not. And then during some work of your drive, data will be erased by the background process, and in the end you will get empty blocks with no data, and SSD will actually returns the real zeros, not hidden zeros, but actually physically overwritten zeros over the previously written data. So this is the idea of trim, and this data erasing in the background is the real problem that we were scared for such a big period of time. Now let's understand the differences between hard disk drives and SSDs. So previously I showed you how quick format works on hard disk drives, and now Before the quick format, we obviously have old user data and file structure metadata is available for you. But after the quick format, the trim command will be enabled and new file system metadata will be written, which is normal, which is obvious. But the second part will be that the actual old user data will be hidden by zeros. So drive will return you zeros, and all the operating system interactions will be done like with the new drive. And in this case, the logical repairing of the SSD, like with the tools that I mentioned previously, it will not be possible because after a quick format on SSDs, we will no more have old metadata information, no old data, only new file systems and zeros, all thanks to this trim operation. So the drive with the trim will think that the data is actually removed from the drive, and therefore it will not return you anything. With using the specific tools, without using the specific tools, drive will definitely think that it is completely zeroed, it is completely empty. So let's quickly summarize what we know at the moment. The chances for data recovery after the quick format on hard disk drives are very high. With SSDs, impossible. This was true until this is actually not the correct slide. I just wanted to mention that on SMR hard disk drives, we are still using the trim command. But how to deal with trim command on hard disk drives, we will talk maybe on different webinars. So this is the story for the next time. So currently, we can easily work with quick format on hard disk drives. We can work with some limitations, or let's say not limitations, but with some additional features on SMR hard disk drives. But what to do with SSDs? How we can deal with formatted SSDs if I just said to you that even drive thinks that the data is gone, the data is deleted, and only returns zeros. Of course, there are options, and the way how we're gonna work with that is the technological mode. This is our biggest and the most popular way of working with the SSDs. Basically, it is the only options that we can use when working with SSDs. And those who are already using our tools are well known with this approach of working with the SSDs. So let's understand what is happening inside the SSD. The data of the SSD can be divided in separate categories. The first one, which is service area, this is a space reserved for firmware, translator, etc. So basically the thing that provides the SSD the possibility to correctly work. Without the service area, the data will not be available because drive will not be able to understand what is happening with it. And of course, it is not available for operating system because in case if it is available, any person can damage it, any person can take a look what's inside, and it's not safe for media storage device, for SSD itself. Then we have user data. This is like the main part of the SSD for owners of this media storage device, because it is actually the capacity where the person who is owning the SSD can use it for storing information, for copying, for deleting, for editing the information. So this part of SSD is available for operating system and available for user who is working with this PC at the moment. And also there could be the hidden data. So this is the part of the data of the drive which is hidden from operating system, which includes the cache and versions of different files. So it is not very big part of the SSD, but it is definitely having some, let's say, like backups. I don't like this word when we speak about SSDs, but for better understanding, we can tell that this is like a emergency backup of some versions and caches of the folders and files from your drive. How the drive can initialize? The CPU will, during the initialization, it will upload service area inside the RAM, and if your service area is all right, if the firmware is not damaged, the data should be returned for you. What possibilities our technological mode apply to you? So with just your normal PC or just some software-based solutions, you can only work with user data, not with the hidden part of user data, but the common user data part, which SSD can return and can communicate with operating system. But with PC3000 tools, you can actually work on a lot lower level with the SSD, basically on the CPU level, which provides you the possibility to communicate with full NAND memory access. So both service area, user data, and additionally the hidden data. But how it is possible? It is possible because with the help of PC3000 systems, we can upload a custom firmware to the RAM which will help us to unlock these hidden features of the SSDs. So what can we get with standard mode? I mean, the mode in which your drive is working in operating system. So if this is the whole capacity and the blue color markings are just the data which is written and not erased, of course, it will be available for you. But after the quick format, parts of the capacity will be erased by trim, and without help of some specific tools or technological mode from PC3000, this data will not be available for you. And additionally, remember that using the technological mode provides you even more access because you can work with service area, you can communicate with the drive on the lowest level possible and get access not only to the hidden data by trim, but to reserved area as well, which can help you to communicate with the previously recorded versions, some cached folders, some cached files, and this is actually the reason why we can bypass trim operation and why we can actually get access to deleted or hidden areas of the drive. So great, we have access to the hidden data, but what to do now? What can help us to get the old files and old versions and old directories? How can we get to the point when we understand that this file is needed and this file is very old and outdated? The general steps of data recovery when you have a formatted case will be very similar for the regular data recovery from SSD. So you will connect the SSD to your PC, you will put it into the safe mode by shorting the specific points on the PCB, upload the loader, which will provide you the possibility to communicate with the service area, build translator, get access to the user data, and get access to the hidden data. This is how we work. But you need to understand that because of the trim, the real user data will be divided into two parts. The new data, which we called other data, which is not needed for us. Yeah, new file system is not important. And the data before quick format. So basically all your previously deleted important files for you. And because we can get access to the very low level, we can actually play with the versions of the translator. So not just upload the latest translator version and see the freshly removed data. But because we have like backups of the translator inside the service area and inside the hidden area, we will be able to play with these versions and rebuild the previously deleted data as well. So this was the idea, but how practically you can do it? First, after uploading the loader, after preparing the drive, the things like, you need to create a translator in the utility, then open the data extractor task, do some additional preparations inside the data extractor, not in the utility. After you created the translator in the utility, that's it. All further steps will be done inside the data extractor. Select the relevant versions of the translator, of the files, of the folders, and save the data. So now, again, step-by-step solution. If you know that the person who brings you the drive formatted it, what you need to do first? Connect the SSD to your PC3000 tool, run the utility, upload the loader, and create the translator. Then you need to do the preparations in the data extractor. You need to create task based on utility of the drive. Why it is important? Because the drive will be initialized in the utility. This is a key part of this process. If you use the port of the drive, of PC3000, you will get the freshly deleted data on the SSD, so only zeros. But if you create a task based on utility, there will be correct initialization of your SSD with versions of the translator, with versions of the files, of the folders, and of the file structures. But to access them, you will need to click Add Drive with Access by Physics, and then Add Drive with translator, with translation and versions. And now it's up to you. You can manually try to rebuild the file system, or you can trust our developers who created like the automatic way of accessing the previously deleted data. After you click the Add Drive with translation and versions, you will meet the virtual drive map. So this drive map will be based on this information that has been taken from all available versions of your translator. And as I said, now you can either manually or automatically select the versions of not only the file system at all, but each separate file can be taken into consideration, and you can check which version of the file is available and which version of the file can be used. And for those who, again, are familiar with our tools, we are using the same approach that we already used for SMR hard disk drives and flash. So based on the different versions of the translator, you can get different versions of the files. It is possible because data is still hidden below zeros. It is still not physically removed. Of course, it depends how much time passed from the formatting of your drive, how much data can be written over the previously deleted data. So of course, each case is unique, but I can say that with this approach, the possibilities of recovery are very, very high. Especially if the person who formatted the drive quickly understands what mistake he made, and if he goes straight to you, the chances are very high that data will be possible to recover, even if we are talking about modern SSDs, which high speed of writing in the background. What are the possibilities? I mean, what SSDs right now we support for this feature? We support all utilities for Silicon Motions, so all supported Silicon Motion CPUs. can use this technology, can use this approach. And this is already added in the current version of the software. The same things goes for Phison utilities. So all supported Phison controllers have the possibility to work with formatted or deleted data. And the next update in the beta version of our software, like 7.8, we added the same possibilities for Maxio Tech controllers, the modification MAS 0902, another very popular CPU chipset on modern SSDs. So this is already available in beta, and surely in the next updates, this will be available for all of you guys. So if you are interested in overall list of supported SSDs, not just for this kind of approach, but for all supported SSDs for different firmware issues, you can scan this QR code, and it will lead you to our blog with the article which we regularly update with different modifications of supported SSDs. But again, remember that Silicon Motion and Phison are the chipsets that are supported at the moment, and Maxio 0902 will be supported in the next updates as well. So I think it's enough for the theoretical part, for the introduction of this technology. And if you have any questions, you are welcome to ask them in chat. And I hope that we will have some time after this webinar to answer your questions. But now let's go to the real life case demonstration. Let me quickly change my screen to be able to share it with you. And we will see how we actually can work with this approach on real life cases. So the cases that I would like to show you today will be based on different drives with different interfaces. And the first drive that I wanted to show you will be the drive based on Phison, hard to see, but it is actually here. It is common SATA drive. The capacity is not very big, 120 gigabytes, but again, capacity is not the limitation here. So regular SATA drive, it has been quickly formatted just to show you what we can do. The next one will be the M.2 SATA drive. So this will be it will be based on Silicon Motion controller. And another very interesting case, because this is actually the future in which we wanna be really quickly. It's this one. It's not the flash drive, but it is actually native USB SSD, which is using the NVMe controller. So developers of the SSDs are switching their aim from just regular PCI Express SSDs to this kind of drives, to just the drives that looks like the flash drive, the form factor of the flash drive. But actually, because of the NVMe controller, they are a lot quicker. And because of the controllers, they can provide the support for different types of chips. So for example, QLC chips, which has a lot bigger capacity than regular flash drives. And in terms of the pricing, this will be just a little higher than the flash drives. So the future of the SSDs will be divided into regular NVMe SSDs and something like this, something that can fit in your pocket, that you can use in your office, at home, huge capacities, pretty quick speeds, a lot quicker than regular flash drives. And I will show you how to deal with such case as well. So let's begin working with the Fusion drive. I will just connect it to port 0 of my PC3000 Portable Pro and launch the full feature mode. So give me a second to share my screen. So those who familiar with PC3000 Portable Pro knows that we have several modes on this tool, and to be able to work with formatted cases, you need to launch the full feature mode, which is red and orange icon. So double click to launch the software. The drive is connected to port 0. Our software detects that this is SATA drive, so let's launch it. Excuse me, didn't check the checkbox of the port 0. Here it is. And what we can do right now. First of all, let's power on the drive and check its behavior. It goes to ready state pretty quickly, so probably there are no issues with this drive, but let's just launch the universal utility just to check if we have the information about the passport of the drive. So yeah, this is the model drive, this is the serial number, the firmware. If I compare it with the sticker on the drive, I can say that it is correct information, and most importantly, the capacity is correct as well. And you know that if we have some firmware corruption, the capacity will be not original. It will be just 0 gigabytes or 1 gigabyte, or some very small amount of capacity will be available in the passport of the drive. And one thing to remind you that even if your drive was formatted and then there were some firmware issues happening on the drive, it is still possible to execute the solution that I was talking about previously. So this is not the solution that you can perform only on fully working drive. First, you can fix the firmware issues and then apply the solution for formatted cases. So we don't have any limits here. And just to show you how this drive will behave in our operating system, if I go to WinDisk utility and mount the drive, this is actually how it will look like in the Explorer. So this is my C drive, this is my L drive, and this is the drive that is connected to port 0 at the moment. Inside, it is completely empty, but you can say, okay, if you launch the quick disk analysis or if you launch the raw recovery right now, we will be able to see the files. So if we try to use the old approach that we are using for hard disk drives, you may think that the data will be available. Okay, let's try. Let's try to do it. Let's go back to the SSD utilities and let's launch the data extractor task. Let's launch the data extractor task based on this drive. So I will create a new profile folder for this Fusion SATA drive. Okay, creating the folder, choosing the PC3000, default settings of the utility, just opening the data extractor task. Right now, if you were working with the hard disk drive and if you launch the disk analysis or raw recovery, you will be able to get access to the data after the quick format. But on SSDs, because of the trim command, you will only see the data which is fresh, which is new. So launching the quick disk analysis will not help you here. Even launching the full disk analysis will not help here because, again, all the data is hidden on the translator level. The latest version of the translator can only see zeros. So this is the freshly written data. If I launch the raw recovery, I will see information about the data which is written right now. If I jump somewhere further on the drive, for example, like 20 million LBAs or 2 million, still no data, 20 million, still no data, and it will go on and on until the end of the drive. No data will be available for you. All the sectors will be zeroed. No matter what sector address I will put here. But the same drive, I will not like do any tricks with my hand. I will go back to the choosing the utility and launch the special utility for this controller. The controller here is Phison 3111. So if I launch the utility for this specific controller, doesn't matter which exact utility, because the firmware is the same on all drives based on Phison 3111. So now I am launching the utility. And what I would try to do, I would put this drive into the safe mode and upload the loader to later rebuild the translation. Rebuild the translator and get access to all the versions of the translator that we get. So give it some time for initialization. Actually, I could just disconnect this drive, short it with the tweezers like we usually do, but I just wanted to 100% give you the proof that I'm not changing the drives or something like this. So what I can do, I can switch the drive to the safe mode, not by the tweezers, but through the software. By doing that, you will see that passport is now new. It's like a template of the passport, and SSD is in the safe mode. Now I can upload the loader. Our software, based on the information taken from the drive, can detect which loader will be the most suitable for it. I can upload the loader, and I can start the translator building. So it will be saved on my PC, and translator building will be started. Actually, I'm not sure how much time will it take. So probably, because this drive is not that big in terms of capacity, it should not take a lot of time. So while we're waiting, I can check the chat if there are any questions from you guys to me. So there is a question if the recording of this webinar and presentation will be available after the webinar. I think yes. Yeah, the recording can be shared. So let me check the second question. Sounds to me like data on older evidence drives like hard disk drives and SSDs not previously available may now be recoverable. Yes, sure. And actually on old drives, yeah, CMR drives, not SMR drives. It should not be a problem, because the way how data is stored on the hard disk drives, it can be stored there for a very, very long time. And even without using this new approach, there is a possibility to get access to it. But regarding the SSDs, definitely it is the thing that you should try. So definitely consider using our tools and our solutions for checking the previously unrecoverable cases. Roughly what percent of the drive is not overwritten by trim on a quick format? It's a good question, and actually currently I can say that modern SSDs, almost all of them, doesn't matter if it is SATA or NVMe or USB based SSD, this trim command will be available on all of them. So this is not the limitation of the SSD. This is the limitation of your operating system. For some reason, not all motherboards may support this feature. Maybe not all CPUs can use such possibilities. So it's more of the question not for SSDs, but for the PCs that you are using. But from my experience, most of the modern motherboards and modern CPUs support this feature. So the chances that you will get trimmed SSDs, the chances are very high. So don't worry, guys, I will check the further questions afterwards, but right now I can see that translator building has been done. So let's go to the data extractor task. Let's create it, and pay attention that previously I created this task based on port, but right now the same folder, SATA, utility. Let's write like this. Click next. Right now I will use utility, not the port where my drive is connected, but the utility. Why? Because first of all, the drive is initialized there, and you can see that the capacity is written right now. Because we rebuilt the translator, because we got access to the service area, it is possible right now to get access to the whole capacity of the drive. So this is the key difference. This is the reason why you need to use utility and not the port. Make data copy, let's leave it by default. Destination device selection by default. And let's see what we get here. What kind of magic our software can do. So if we go to Explorer, where our file system should be available, we can actually see the same results as before. So no magic happened yet. But the key feature right now is that we are using data extractor, and the data extractor task is based on utility of this drive. So what we can do? We can choose our drive, click working with the utility, and add drive access by physics. So not through the latest translator that is uploaded to the SSD at the moment, but through physics, through accessing the sectors one by one. We can see the new drive, and if we try to open it, we will not see anything new. We will see just the empty NTFS file structure. But if we go again to work with the utility and to this image by physics, we add all the translator versions that we got, it will be possible for us to start analyzing the results. So take a look. In the log, you can see that a lot of previously recorded versions has been added to the drive. And in virtual drive that we created, we can now work with the new file structure. By default, it will be freshly formatted, so only new data is available. But because we can go and edit this virtual drive, this part of screen will be very familiar for those who are using Flash, PC3000 Flash software hardware solution, because in Flash we can play with different versions of the files as well. And now it is possible to do with SSDs. So if we open the file structure, we can see again the new data. But on each step, we can play with different versions, with different metadata, with different versions of master boot, with different versions of root folder. And if you don't want to do it manually, you can always right-click your file system and find the option selection versions for metadata. What will happen right now? Right now, our software will scan all the metadata for both new file system, for previously recorded file systems, scan the MFT, and try to add, try to combine all of this data and add all the available versions for you to the root folder. automatically. As you can see, I didn't change the versions. I just clicked this option and the data is available. And to be sure the data is available, I can click headers control. We can see that all folders are now green. Yeah, so it's not like it's not like it's available but not possible to recover. No, it's actually visible. If we open the sectors of each file, it will be available. And if we open the files themselves, they will be available as well. So all of this data will be available for you with no limitations. If we go back to our original menu, yeah, give it a time. I was too quick. The software was trying to check headers on each file, and now we need to wait a bit to go back to the main menu. But you can see the data is available and we can save the needed information without any problems. We can do the whole image, we can save the data one by one, I mean file by file. We can do whatever we want. So if we go back and refresh this result, this is what we get. Our root folder now looks a lot better with previously deleted data available for us for analysis, for saving, for imaging. So this was an example on Fission drive, on Fission-based drive. And right now, let's disconnect this drive and let's connect the the second one, the Silicon Motion drive. I am showing you different drives just to show that no matter what type of SSD you are working with, no matter on what type of supported CPU it is based on, the approach is completely identical. And this drive, yeah, this SATA drive, this Fission-based drive, was in fully working state. So I could show you that the data is available. But the second drive, the M2 drive, will be problematic. It will have some issues. And to prove it to you, I will turn it on, launch the universal utility. Oh, I lied to you. Then it is the third case probably. This drive, as you can see, is again available in terms of the capacity. And if I go to WinDisk and mount this drive, again, it will be completely empty. So completely identical drive, just based on different chipset. And if we go back, and this drive is based on Silicon Motion 2259 XT. So as you see, I don't even pay attention to the vendor of the drive. I am just choosing the needed utility based on my CPU controller. I mean, controller, yeah, not CPU, and launching the utility. This drive is Radeon R5. I mean, utility is Radeon R5, but actually this is some kind of different vendor that may not be even available in your country. Maybe this drive is from Europe or from Africa or somewhere else, because the Silicon Motion, Fission, and Maxio CPUs can be purchased by anyone. You can find completely new vendors of the SSDs based on the already supported CPUs by ASLab. What I'm doing right now, because our software can automatically put the drive to the safe mode, you saw that I am starting to upload the loader. The loader that I uploaded has a version U0916A0. But when we tried to upload this loader, we actually noticed that the firmware version, internal firmware version of the SSD is different. And our software can select the different loader based on your drive, automatically, again, it will be highlighted, so no problem for you. Even if you don't have a lot of experience working with SSDs, the developers of SSD utilities tried to automate all of these processes. So you just don't need to think twice before clicking anything. Everything is automatic. So uploading is happening of the loader. It's not the translator building, it's just uploading of the loader. For those who may not know what is loader is the microcode that we uploading to the RAM, which provide us the possibility to communicate with the service area. Because when you put the drive to the safe mode, it is not communicating with the chips at all. So let's give it some time. So while we're waiting for different drives, as you can see, the time of uploading the loader can be different. For previous drive, it was faster. Here, it take a little bit more time. And actually not to sit here and look at the monitor, I just want to upload the previously built translator. I did it before this webinar just to save our time. How to do it? We need to go to completely the same menu, tests, service information, translator, but instead of creating the translator and spending like 15-20 minutes, I can just load it from file because I already previously did it. So where is, here it is. Data, translator, autosave. Each time when you create a translator on your drive, it will be saved in the data translator autosave folder based on the time date when you start doing it. So in case if you want to try with one loader, create translator, with another loader, create translator, it can be done with no limitations, and all the versions of the translator will be saved there as well. So now, after uploading of the loader, after initializing the drive, we can go to data extractor, create a new case for this M2 drive. M2 formatted, M2 formatted drive. It is Silicon Motion once again. Again, we're choosing utility. Next. Of course, settings of the utility can be changed. You can change the destination drive. You can choose which port you want to work with. It's up to you. So again, approach is identical. If we go to to original file structure, in this case, we can even see that after formatting, the file system is not available for whatever reason. We can execute the quick disk analysis immediately, but I don't think that it will be very helpful here. So again, not to waste your time, let's close this part and let's try to work with these drives, with this drive by physics. Creating a new drive. On this new drive, we are adding all the versions that can be taken from the service area and from the hidden area. Pay attention that for this drive, our software needs to re-upload the loader and re-upload the translator, but because data extractor task is based on the utility, it is doing it by itself automatically without me even clicking anywhere. So if we go further, we can see the file structure. which is available finally, but this is new file structure. So on this drive, physically it's okay, firmware it's okay on this drive, but there are some issues with the file system. We managed to recover the file system, but file system is new. It's not the data that we are looking for. Again, right-click the virtual drive, click Edit, and now feel free to play with the different versions of the data. So the sky is the limit here. And if you want to do it manually, as I was saying, it's completely available for you as well. But not to waste your time, I just click selection versions for metadata, scan MFT, and we can launch the automatic scanning and automatic assembly of the data. Again, depending on how many data you have, depending on how many times you formatted the drive, it can take different amount of time for analysis. The results can be different, but because even after the quick formatting, the chances that the drive will overwrite previously written data, it's not very high. So the drive will go for some different sectors to write the data first there, and only then it will go to the sectors where the data could be possibly some time ago. So again, data is available for us, and if we go to headers control, let's try to open some pictures. I'm sorry for those who don't like insects. Let's try something else. Maybe some better pictures will be available here. I'm opening a pretty big picture. Let's take a look if it can be opened. Yeah, no insects, just flowers. Everything is good. Everything is all right. So this is how you can work with silicon motion drives. Completely identical approach. Different loaders, obviously, different utilities, obviously, but the steps that you need to do, completely the same. And just last example for today will be on this SSD, which looks like the flash drive. So again, the future of the SSDs. Because I'm working on portable pro system, there is no limitation for me to connect this flash drive directly to USB host port. Power it on and launch the utility for the CPU, which is the heart of this drive. So let's try to launch the software. So we are seeing some issues right now, but it is not actually the issues. It's just because we need to short the drive with tweezers. So with this case, there is no way how we can put this drive into the safe mode automatically, via the utility. So I will use my tweezers and short this case manually. Just give me a second. I will need to find the position that I need to short. So just a moment. Let's click cancel and choose the different utility. So just a second. let's restart the software just in case. And let's launch the utility for this USB-based SSD. So through this utility, it was possible to start with the drive. After shorting of the drive into the safe mode, as you can see here, it is possible to upload the loader. And for this particular drive, the capacity is higher than on previous drives. So definitely we will not wait for creating the translator in the real time. I will just upload it from the profile folder, because the bigger the capacity, the more time you need to spend for building the translator. Go to tests, service information, translator, load from file. Right now, I'm just creating the profile folder and finding the profile folder with the translator for this webinar. So uploading has been started. Okay, test completed. So now just the data extractor task opening, correct creation of the task based on the utility. So USB formatted, choosing the utility, you can see that the capacity is much bigger. So previous drives were around 120, 128 gigabytes. This one should be around 500 gigabytes. So just on one chip, just on one small PCB. And yeah, I was right, around 500 gigabytes. So here it looks like file structure is available, but not really, because it's new. It's freshly quick formatted drive. But again, if we go to drive by physics, and later if we upload different translator versions, it should be all right for us. Don't pay too much attention for the errors that you are seeing during all of this during all of these actions being performed, because you need to remember that SSDs are not the hard disk drives, and the way how data is stored there is different. On SSDs, data is stored inside the chips, inside the cells, and if SSD is not working for a lot of time, for example, or if it was working for a lot of time, for a big period of time, constantly rewriting itself, the charge inside the cell can leak. And that's why, because we are scanning all the translation, all the versions inside the service area, some data may have bit errors inside. This is exactly what the utility is showing us, but it's totally normal. It's okay. There is no way that you will work with the SSD, which is 100% good dump without any without any bit error. And again, here, because the capacity is a lot bigger, we need to scan a lot more information, a lot more data. So while we're waiting, let me check if we have any more questions. What happens if quick format was repeated several times? As I mentioned during like a couple of minutes ago, even if you perform quick format several times, the versions of the translation will still be saved somewhere inside the SSD. So theoretically, it may be problematic, but probably you will just need to scan more. You will just need to wait a little bit more time because the different versions will still be available for you. Okay, you refresh the drive once, you refresh the drive twice, but previously written data is still on the drive. So for me, I don't think that it will make a huge difference in terms of that. Is the drive your data recovering from write protected? I don't know actually, and for us it doesn't matter because the drives that we are working with looks like this. Yeah, we are connecting the drive through the SATA or through the NVMe or through the USB port directly to our tool. And because we are working below like its operating system, let's say on the very low level access, for us it's not actually a problem if it is write protected or not. If SSD is overheating, then in this case, what will be the approach? If your SSD is overheating, this could mean that there is a physical issue, not the issue with the firmware. Because why SSD can overheat? Because maybe there is some kind of short circuit somewhere on the PCB. In this case, I would suggest to either inspect the drive with the heat scanner and find the position, find the part of the SSD that is overheating. Because if it is some kind of capacitor or resistor which is overheating, after just changing this capacitor or resistor, the problem can be gone. So the drive will continue working normally. If your controller is overheating, in this case, again, this can mean that maybe there is some kind of physical issue. Maybe there was the electricity jump, which caused some internal physical structure to become corrupted. In this case, the suggestion would be to find the identical donor drive as close as possible. The same vendor, the same capacity, the same controller version, which is the most important part, and and just swap the NAND memory chips from your patient drive to your donor drive, because there are no like some secret keys stored in the CPU, stored in the controller. There should not be a problem for you to work with the drive. So this is what I would suggest for you in this case. Let's see what happened after the virtual drive building. And in this case, we even more lucky. We don't even need to put the to analyze the data further, because data is already available for us. Like we can see folders which are available. Let's see if they are actually openable or not. Yep, the data is available here, so we can choose headers control and we can see that it is already available, and we don't even need to manually adjust the versions, manually put the folders and files in the different places. All has been done already by our software. So regarding the real life cases, this is everything that I wanted to say. And now let me just quickly summarize the advantages of our approach and advantages of our tool. So PC3000 SSD add-on is the only existing solutions for formatted and deleted SSD. Plus, of course, because of these softwares, because of these utilities, you can not only work with formatted or deleted SSDs, but with SSDs that has some firmware corruption. To use this method, your SSD controller must be supported. So Currently, it is Silicon Motion and Fission plus Maxio in the beta version. Later, we would work, our developers would focus on adding more popular controllers to support these kind of features. It is possible to recover the data even if it was deleted months ago. Why? Because SSD can store all of these different versions of the translator somewhere in the hidden area, and theoretically it should be possible. But of course, each case is unique, yeah, and each case need to be analyzed to get as good result as possible. There is an option to trace previous file versions and roll back the file history. Because you can play with versions of the files, you can check how the file was changing. For example, if we are talking about some kind of big document which has been changed, you can roll back and see the different iterations of this file. With this approach, it is possible to scan all area of an SSD, including the relocated and unused blocks. And the safe mode is optional but not critical. As I showed you, the first two drives, you don't even need to put this drive to the safe mode because our software can automatically upload the needed loader or rebuild the translator even if your SSD is in good condition and you don't want to put it to the safe mode. So yeah, this is basically it. And I think it's time for me to put my word to Max. So
all right, George, thank you. Thank you so much for this excellent presentation with real life cases. Don't let me also start to share the screen.
Yeah.
You can stop this meanwhile.
Just a second. There you go.
All right. So as far as I see, we still have some questions which haven't been answered yet. George, if you take a look at the form.
Yeah, sure. You want me to answer them right now or?
Yeah, I think it makes sense because right now, guys, by the way, do you see my screen?
Yep.
Excellent. So as you see, the quickly formatted SSDs is not a big problem. It's not such a huge challenge for you guys. So if you have some thoughts, by the way, while George is going to provide some answers on some questions, you can share your thoughts in the chat group and provide some comments. We would be gladly ready to provide answers on them. So actually, it's very interesting. How frequently are you dealing with such kind of cases, and what are you usually doing when you have this? It's really curious for us to know because, you know, some of the data recovery engineers are really struggling with this because they're making data recovery tasks on the regular basis. But some of you guys, I'm sure, are coming from the digital forensics area, and it's really interesting to know the statistics. What are you doing and how you're struggling with this?
Yeah, so
Okay,
while we're
George.
waiting, let me quickly answer two remaining questions. So the first question is, will re-examining the same drive impact the results or data inside the drive? Actually, no, because our solutions are working through the RAM. You should not be scared that some data will be lost, that some data will be deleted or changed or anything like this. It cannot be happening. Our solutions are in RAM, and for the drive, it is safe. So it should not be a problem for you. And the last question that I can see in form at the moment, if a deleted file is recovered, will the software mark it as recovered deleted? So it depends. In this case, I was showing you the situation when we recover the data after the quick format. But if you are working with deleted files, not the fully rewritten file structure, but some specific deleted data, there is a button in our software, show deleted. And these files in the file structure, they will have a different like small logo around it. So you will notice which file was was deleted and which files were original. But in our cases, there was no deleted files. There was formatted file structure, formatted file system. So that's why it was just showing as green color near the folder and near the file.
All right, George, we've finished, right, with everything?
Yep.
All right,
At
so
least for the moment.
all right, maybe later on you would be able to provide some answer some questions. And so all of these real life cases have been solved with the PC3000 Portable Pro. And if you see, this device covers almost every type of storage media which exists nowadays, starting from the classical hard disk drives, talking about different types of solid state drives, including NVMe interfaces. And as you can see, there are a bunch of different adapters which are coming along with this delivery kit. And this is not only the SSD and HDD solutions. So there is also flash solution, but in terms of the logically damaged flash drives, USB drives, SD, micro SD cards. And so if you have some issues with the logical level, you can easily put this logically damaged flash pen drive to the portable, and you can successfully recover it. And of course, for the RAID cases, the Portable Pro has a special RAID add-on. It's a software array add-on which allows you to struggle with the real complicated configuration of RAID systems which are damaged. And as you can see, this Portable Pro device has 3 ports for NVMe SSD drives and 1 port for the USB host. Yes. So, for instance, you can deal with 3 NVMe drives at the same time, and an extra port when you try to connect the USB HDD, for example. So, in total, it has 4 ports. So it's a new generation of the portable device, because previously the portable was able to deal only with one NVMe SSD at the same time, but right now we support 3 SSDs. So, and generally speaking, the Portable Pro has 3 modes. We call it standalone mode, when you can deal with Portable Pro and connect some of the drives without laptop or desktop and provide some quick diagnostics and understand what's going on. In easy mode, which is aimed for the regular simple tasks, which doesn't require a lot of experience and dealing with PC3000, and of course fully featured mode, which today George demonstrated, because fully featured mode, it's a very flexible mode, fully fledged mode, which allows you to deal with real complicated cases, not only with like quickly formatted SSDs, but a lot of magical, seems to be unsolvable cases. Everything is possible with the fully featured mode. And maybe for some of you guys, it's important to know that this device has physically write protection button. So when you try to connect, when you're connecting to some of the examined storage media, and you want to be sure that there is no any impact of the data, you can just switch on the write protection button, and that's it. And you can configure this write protection button for different ports. As you can see, you can set settings for port number 0, 1, or 2, and not to allow make some writing processes in these ports. And finally, what we can say about the Portable Pro unit. So this is very universal for different types of storage media. It has 4 ports, and it works with 3 SSDs based on NVMe interfaces. And you can also make imaging tasks using this device. And it's equipped with a touch screen and a oscilloscope feature, which sometimes very helpful when you try to identify what is the root cause of the damaged hard disk drive. But this is a little bit another story. And as the Bill mentioned at the beginning, we're going to have the training class in Norwalk provided by the instructor Daishi Magaito, and the training is going to be in March and the end of June. So you're welcome to get in touch with the Tiltech team and get some further information about this. And of course, upon training completion, everybody will be provided with the authorized ACE Lab certificates of attendance. So you're welcome. And of course, we will demonstrate. You would be able to play and real life cases yourself. And what is the main important to mention about our training courses? We don't teach you how to proceed with from step A to Z. Yes, we teach you with the troubleshooting skills, not to feel frustrated if something goes wrong. Yes, we're teaching you how to feel free and comfortable with every really complicated cases and to solve it yourself. And of course, just a few words, we have to mention that our solution is not only about training courses and tools. We provide regular software updates. We provide regular training technical support assistance as well. Our solutions are also coming with a lot of tutorial resources like user manuals, blog, forums, YouTube channel. And you're welcome to join to this knowledge base with the PC 3000 technologies. And we would be glad to see you among the PC 3000 users here. So, and this is it for today. I very appreciate you guys, your time. 1.5 hours have been passed, and this is it. I hope you enjoyed this webinar. Later on, we will share the presentation slides and video. As far as I understood, we provided video recording, Bill, right?
Hey Max,
Mm-hmm.
hi. There was a question that came in a couple of minutes ago. And I'm
All
sorry, I
right.
popped back on. Uh, I don't know if George answered that last one that came at 2:28.
So
Um,
let me quickly check it. Can you tell me
sorry,
about what? What was the question?
SSDs are always changing.
Yeah, I see it. Just a moment. Let me read it completely.
And while he's doing that, I'll just thank everybody also for joining this webinar, and George and Max for presenting it. Yeah, there's info on the site about the classes in the U.S. There will be classes in Canada as well. They'll have those on their calendar pretty soon as also. So, um, yeah, we look forward to having you here in Norwalk or wherever we're holding the classes.
Yeah, so regarding the last question, what I can say is that if you are using our tools, we are working through the technological mode, and therefore the SSD is not working in the standard mode. It will not have access to the data all the time. So the chances that something will be changed, as I said, are there is no chance. And therefore, when you start working, you need to put it to the safe mode, yeah, or just connect to the utility, and all the background processes will be stopped. So therefore, there will be no changing, and that's why you can compare the hash sum before and after and see the results for yourself. So just because, again, we are working below the normal operating system of the drive.
Thank you, George.
Mhm.
All right. On that note, I think we're going to wrap it up here. It has been recorded. I think Kent will either have that available upon request or it will be available. So thank you, everybody. Have a great rest of your week.
Thank you to
Thanks, Max
everybody.
and George and
Yeah.
Thanks,
Elizabeth as
Bill,
well.
George, Elizabeth. Thank you, everybody.
Take care.